There's one more type of asymptote that we can see that we're going to talk about in this section, and those are called slant asymptotes. And they are like they sound, they are diagonals instead. So instead of having the graph split or kind of follow that pattern, that leveling off at a vertical or horizontal line, it happens at a diagonal instead. And these happen in very specific cases. So the graph of a rational function has a slant asymptote if the degree of the numerator is one more than the degree of the denominator. So it's specifically one more. And then we can find the equation of the slant asymptote by division. So let's go ahead and, or by long division, which we've already learned. Or if you have a specific case, you could use synthetic division, but always long division will work there. So what happens is when you divide, you end up with some piece here that is of a linear equation, and then you have your remainder. If your remainder is 0, then that's fine too. So let's go ahead and test it out. So notice how my numerator has degree equal to 2, right? And my denominator has degree equal to 1. So what happens is the numerator is 1 more than the degree of the denominator. Now, a slant asymptote is totally different than a horizontal asymptote. So, we're asking two different questions here. And same thing with vertical asymptotes. We're asking totally different questions. So here on numerator, degree is bigger than the denominator degree. So it would not have a horizontal asymptote. But it could have a vertical asymptote. As long as this was simplified, we could check that. I don't think you can cancel anything here. So this one would have a vertical asymptote, and a slant is different. So just keep in mind that these are 3 different kinds of asymptotes. You'd want to look at each of them individually. So this one does have a slant asymptote. And what we do is we can do this by division. So you can either do long division and divide it out this way, or this is of the form x minus c, so you could use synthetic here. Okay. It depends on the case though. If it's not of the right form, then you would have to do long division. So it's not that every form always uses synthetic. You want to be careful there. I'm going to use synthetic division because it's faster. So my c value here is 3. And then my other values would be 1, -4, and then -5. So I bring down the 1. 3 times 1 is 3. Here when I add, I get -1. 3 times -1 is -3, and I get -8. So this part becomes just 1x minus 1, and then this is my remainder. Remember, when using synthetic division, you start with 1 power less. So because my power up here was a 2, my answer starts with the power of 1. So this is equal to x minus 1 minus 8 over x minus 3. And then this right here is your mx plus b part. So y equals x minus 1 is the equation for the slant asymptote. All right, so let me show you what this looks like on Desmos. So we'll save us the time of graphing this one by hand, since we already did quite a few. All right, so we have x squared minus 4x minus 5, and then we had x minus 3. Let me zoom out a little bit here so you can see that. And I'm also going to graph the equation of the slant asymptote, just so you can see it was x minus 1. Oops, 1. And again, I want to change that to a dotted line because technically that is not on our graph. I'm going to make it, let's stick with purple, I guess. And you can see, so you can see here how that asymptote is kind of hugging that line, or sorry, the graph is hugging the line of the asymptote, I should say, right? So you have this kind of diagonal piece here. You do also have a vertical asymptote. Notice how the denominator would be 0 at x equals 3. So you do see two asymptotes in this particular case. I know it didn't ask us for it, but if you were graphing it, you would notice that you have that slant asymptote in this case, and you also have a vertical asymptote. So as you're graphing, then adding the slant asymptote into the picture is now another piece that you really want to check. When you do your asymptotes, check to see if there is a vertical, check to see if there's a horizontal, and then check to see if there's a slant asymptote now. And then, of course, you're finding extra points as needed to graph. All right, let's do one last example here. We haven't done an application in a while. There are actually a lot of applications here. The material is just very dense, so we're only bringing a handful now and then. Well, this is a nice one. So there is a virtual reality headset that enables users to experience video games as an immersive, like 3D environment. So it feels like you're actually there. And we're going to talk a little bit more about this. And I believe there's more information at the start of the chapter as well, if you want to read more about it. So let's suppose the company that manufactures this invention has a fixed monthly cost of $600,000, and that it also costs $50 to produce each headset. So what you often have with cost is some sort of fixed cost that doesn't change from month to month. You know, this could be basic operations, maybe things like payroll, right? So if your employee base is pretty stable, you don't have a lot of turnover or new hires, at least for a short period of time, your fixed cost, that could be a fixed cost for you. Or maybe you're incorporating some of your utilities there that tend to be pretty fixed from month to month, right? So maybe if you have an electricity plan and you pay the same bill monthly, that could be a fixed cost, et cetera. And then there's also usually variable costs, which are specific to how many of that item that you produce. So it's $50 for each headset. So if you only produce 100 of them, then you only do 50 times 100. If you produce 1,000, then that cost becomes 50 times 1,000. So that's why it's variable, because it changes based. So first here, we want to write the cost function for producing headsets. So we're going to use C for cost. And like I said, you're going to have a fixed cost in most cases, plus a variable cost. So in this case, our fixed cost, so this is a C and this is parentheses, would be that 600,000. And then the variable cost is $50 for each headset. So we're going to use X for our number of headsets. So it's headsets. So it's going to be 50X here as our starting part. Now, B wants us to write the average cost function. So notice it's very similar, but we're talking about an average cost. So think about what an average is, right? In an average, you take your total. So your average is a total divided by the number of items, right, that you've added together. So in our case here, what happens is the average cost, and you're using the notation of the bar on top to mean an average. That's a pretty common notation. We use that in statistics as well. Is going to be our total cost. So our total cost is 600,000 plus 50x divided by the number of items we produce. So your number of items that you're producing here are the headsets. So you produce X headsets. So that is your formula for your average cost here. And we're going to find and interpret our three values. So I want to plug in 1,000 and then 10,000 and 100,000. So let's plug in one at a time. So I plug in 1,000, I have 600,000 plus 50 times 1,000 all over 1,000. So I have 600,000 plus 50,000 all over 1,000, which is 650,000 all over 1,000. And then you can, of course, simplify here. So I can cancel the 3 zeros and you're left with just 650. Now this is a cost, so this is going to be in dollars. So what does this mean? This means that the average cost of producing 1,000 headsets per month is $650. And remember, this is per headset. So you may be saying, but I thought it was only $50 to make a headset. So what the average cost is it takes into account the fixed cost as well. So even though it only costs $50 additional to make the headset, you still have to pay your employees. You may have to run the factory. You have heating and lighting and water and all that other stuff that has to get paid too. So realistically, it's actually going to cost you $650 a month for each headset produced when you look at it as an average altogether. Now, they want us to also plug in 10,000 and then 100,000. And I'm going to give you the answers here. I'm going to encourage you to pause the video and try it at home, but it's going to be very similar to what we just did. And let's see, when you plug in 10,000, you get 110. And when you plug in 100,000, you actually get down to 56. So for instance, here, the average cost of producing 10,000 headsets is only $110. Again, this is in this reference of per headset. And then for 100,000, the cost was down to 56,000. Why that's happening is because you're taking that fixed cost and you're dividing it over more units. So because you're producing more, then that cost per unit makes the overall total look different, right? It's still the same fixed cost of 600,000, but now you're breaking that into 10,000 units or 100,000 units. So again, we're looking at putting that whole cost together. So what we're noticing is as we produce more and more headsets, that cost is going down overall, right? I mean, I should say not the overall cost. Your overall cost is still the same, but the cost per headset is decreasing. So the last thing is, what is the horizontal asymptote for the graph, and describe what it represents for this company, excuse me. So our horizontal asymptote, and again, we're looking for the average cost function here. So notice that we could actually rewrite this as 50x plus 600,000 over x. So you have the same powers here, right? So I have that same power. And if you go back to, see if I can find it. Your little cheat sheet there for horizontal asymptotes, when you have the same powers, then the horizontal asymptote is the ratio of the leading coefficients. So our ratio here would be 50 to 1, which is 50. So this is for part D here. So our horizontal asymptote is equal to 50, y equals 50. So what's happening here is that the more and more headsets we produce each month, the closer to the average cost per headset for the company comes to 50. So this is the least possible cost that we could have in this case. And if you graph it, let me see if I can graph this real quick so you can see it. All right, let's clear some of these out. All right, I have to zoom out a lot here. And let's look at the horizontal asymptote of 50. 50. Let's change this color. We'll make it purple. Okay. So what's happening here is that we do have a horizontal asymptote of 50. Now, one thing I will note is this is a real world problem. So it would not make sense to have negative values here. So really we would ignore this half of the graph, right? We're not making negative headsets. So we're really focusing on the positive part of this graph, which looks like this. And you can see that as we make more and more and more headsets, that line is getting closer and closer to 50. So our average cost starts to run towards 50 for each headset as we make more and more and more of them. So that's what's going on here. Now, I will note that we're just looking at costs in this case. And of course, you have to think as a business of other things too, right? So there is a point when you're selling items where you're going to reach that threshold of people who want to buy them. So even though our horizontal asymptote approaches 50, as we make more and more and more and more, it may not make sense for us, let's say, to make 1 million headsets a month if I only have 100,000 people who are buying them. So even though that average cost is going down, in the real world, if you're talking about business models, you have a balance there, right? You have supply and you have demand as well. So you want to also balance the idea of cost with your profits to make sure that you're able to sell what you make. So ideally in the real world, you would make exactly what you need to sell every month. That way you don't have to store inventory and you don't have those additional costs. Realistically, that doesn't always quite happen, right? But that's our goal, is that we could really make exactly what we need each month and sell every single item so that you're meeting your demand, but you're not exceeding it. And that, you're not going under it as well, where people are waiting months and months and getting frustrated for the product either. So just kind of a little side note here that it's great that our value goes to 50 for that average cost, but you also have to balance that with the idea that, we're not maybe going to make 1 million headsets a month, or maybe we are if people want to buy them. So that also comes into play here when we're talking about business ventures and starting a company.